Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogwood Jr., your math tutor. I am an instructor of mathematics at the University of Liberia. In today's lesson, we want to look at implicit differentiation along with the natural logarithm functions. So in previous lesson, we solved a lot of problems under implicit differentiation. So we want to solve the 19th problem under implicit differentiation using the natural logarithmic functions. So we have x plus 1 over x raised to the power x plus x raised to the power 1 plus 1 over x minus y equals to 0. Now why is it that we call this an implicit equation? Because x and y are mixed up. That is, y is not the subject of the equation. So when we differentiate y, we will attach y prime because y is the name of the function. So now how do we go about finding the derivative of this kind of function? So for this kind of function, you cannot just take the ln on both sides. Even if you make y the subject, by sending y on the right hand side of the equation, you cannot just take the ln on both sides, because our first and foremost concern here is to ensure that x is placed downward and that of 1 plus 1 over x is also placed downward. We don't need these kind of powers. And also you cannot use the power rule or extended power rule because these powers are not numbers. They are not real numbers. So when they are numbers like 2, minus 5 and so forth, half, whatever the case might be, whatever number you have, then you can use the power rule. That is, you bring the power down, subtract 1 from the power. But it's not the case. So what we are going to do here is that we are going to deal with the terms separately, especially for these difficult terms, this first term and the second term. So we want to deal with them separately. So for the first case, we say let r equals to the first term, x plus 1 over x. Now 1 over x is the same as x raised to the power minus 1 or raised to the power x. So let r be equal to this expression. Now to get this x down, we have to take the ln on both sides. So we say the ln of r is equals to the ln of x plus x raised to the power minus 1 or raised to the power x. So what happens, this x comes down because we know that the ln of a raised to r is equals to r, the ln of a. So we have the ln of r now equals to x, the ln of x plus x raised to minus 1. So the next target is to find a derivative. So to differentiate natural logarithm, the rule there is 1 over the function r times the derivative of that function. The derivative of r now is just r prime. The derivative of r is 1, but since r is the name of this function, so we attached r prime. So for this case, we're going to use the product rule because you have two functions being multiplied by each other. So we use the product rule. That is, we hold one of the function, we hold x, and differentiate the second function, 1 over whatever we have here, x plus x raised to the power minus 1, times the derivative of what is in here. So the derivative of x is just 1. Then the derivative of x raised to the power minus 1, you bring this minus 1 down, is minus 1. Times the derivative of this x. Now, if we subtract 1 from this power, it's going to be minus 2. So we held this x and differentiated the ln. So we can now hold on to the ln and differentiate x. And the derivative of x is just 1. Now we can simplify. So we have r prime equals. Now I'm going to rewrite these expressions. So you have x. Now this is 1 over x plus 1 over x. Because 1 over x is the same as x raised to the power minus 1. Times 1 minus 1 over x squared. Plus ln of x plus x raised to the power plus 1 over x. So we have r prime now to be equals. So we can work right here. You have 1 all over. So this can be x times x squared plus 1 all over x. And then times x squared times 1 is just x squared minus 1 all over x squared. Plus ln. Now x times x is just x squared plus 1 all over x divided by r. So this x goes in the numerator. So what happens? This is x times x gives us x squared. So this x squared can cancel this x squared. So r prime over r is just equal to x squared minus 1 all over x squared plus 1 plus the ln of x squared plus 1 all over x. But we need to multiply this r by what is on the right hand side. So we have r prime equals to what is this r? So let's bring it downward. So we have r now to be r prime is equals to this is r, and then multiply by this entire expression. So our r now is this r is the first term here. So we now have x plus 1 over x raised to the power x, and then times this entire expression, which is x squared minus 1 all over x squared plus 1 plus the ln of x squared plus 1 all over x. So this is the first derivative, the derivative of the first term. Now let's find the derivative of the second term. So the second term, we can say let p equals to x raised to the power 1 plus, we send this x in the numerator, it becomes x minus 1. And then we take the ln on both sides. Ln of p is equals to the ln of x raised to the power 1 plus x raised to minus 1. So this power will just come behind the ln. So we have ln of p is equals to 1 plus x raised to the power minus 1 times ln of x. Now we find the derivative. So this is 1 over p times the derivative of p, which is just p prime. So we hold this factor and differentiate this one. So it's 1 plus x raised to the power minus 1 times the derivative of x, the derivative of ln of x, which is just 1 all over x. Or we can just rewrite this x raised to the power minus 1 as 1 over x. Plus, now we held this one first and we differentiated this. So let's now hold ln of x and differentiate this one. So the derivative of 1 is just 0. The derivative of x raised to the power minus 1 now is minus x raised to the power minus 2, because we bring this power down and subtract 1 from the power. So now we can simplify. So we have p prime over p is just equal to, now the first one you have 1 all over, let's say we have x times x is x, x times 1 is x plus 1 all over x times this x will give us x squared plus, this is negative now, this x raised to the power minus 2, so it can just be x squared, positive x squared. So now p prime would just be equal to, because this p can also be attached to this, so p prime is equal to p times this expression. What is p? This is our p. So p is x raised to the power 1 plus 1 over x times x plus 1 plus the ln minus the ln of x all over x squared. Because the denominators are the same, we just take one of them. Okay, so now let's write our final answer. So we differentiate this, we get this one, which is x plus 1 over x raised to the power x times x squared minus 1 all over x squared plus 1 plus the ln of x squared plus 1 all over x. So this is the derivative of the first one, plus the derivative of this second term now is x raised to the power 1 plus 1 over x times x plus 1 minus the ln of x all over x squared. And then if we send this y across the equal sign, we're just going to have positive y, just like this. So what's the derivative of y? It just equals to y prime. So this is our final answer for this problem. So thanks y'all so much for watching. See you in our next lesson. Please don't forget to subscribe, to like the video. You can share as well, but please don't forget to subscribe. Thanks y'all so much and see you in our next lesson.